Okay, here, and I'm sorry about the bad formatting. That was my fault for not checking that before I printed. Okay, we're looking at one of the reactions that actually occurs whenever your airbag needs to inflate, okay, and it involves sodium azide, okay. So we have the decomposition of sodium azide into sodium and nitrogen, okay. We get a metal, but we also have this large amount of gas, and you'll actually see volume-wise here in a little, well, soon, okay, and that's actually what inflates your airbag here, okay. We want to determine the mass of nitrogen produced from the decomposition of 100 grams of sodium azide. Okay. First thing I want to do, I'm going to rewrite my equation down here and make sure it's balanced before I begin. Okay, so I've got sodium azide that's decomposing into sodium and nitrogen. Okay. Here I see that I've got 1 sodium and 1 sodium. I've got 3 nitrogens and 2 nitrogens. So the only way to make 3 and 2 the same number is to try to make them both 6. So I'm going to multiply that 3 times 2 to make 6 nitrogens, and then this 2 times 3 to make 6 nitrogens. However, this also gave me 2 sodiums, so I need to multiply that 1 sodium by 2. So I've got 2 moles of sodium azide will decompose into 2 moles of sodium and 3 moles of nitrogen gas. Okay. Now let's look back at the problem. Okay. It says determine the mass of N2 produced from the decomposition of 100 grams of sodium azide. So I've got number, unit, substance. Go ahead and scratch that out. Okay. So this is what I know. And I'm asked to find the mass of nitrogen produced. So this problem is a lot like the previous problem where they gave me a mass of one substance and asked me to find the mass of another. So this is going to be our bigger stoichiometry problem where you're going from mass to mass. Okay, this is the most steps that you'll do for one stoichiometry problem for right now. Okay, once we start giving the math that you're doing an even bigger application, you'll do larger total problems, but it's really just this is the biggest type of problem that's just one step to the overall question that you are answering. But you'll see that, and it actually is pretty logical, so bear with us. Okay. Here, I'm going to start with what I know, just like always. Got 100 grams, so I'm going to put 0.0 grams of sodium azide. Okay. And I don't want to talk about grams of sodium azide anymore. I want to find the mass of nitrogen. So, got to cancel out my grams of sodium azide. Okay. Alright, so I want to cancel out my grams of sodium azide. I got to see what I'm going to put in my numerator now. Okay. Now, in the previous problem, I mentioned, and actually in a few problems where we've dealt with mass, okay, I've mentioned that the only thing you can get to directly from grams is moles of the same substance. Okay, but if you like to kind of have a couple different tricks in your little toolbox to use, my big thing is I know that if I'm talking about sodium azide, but I'm asked to find something for nitrogen, the only way I can get from A to B is to use a mole ratio, which means I have to know the moles of this guy, then do my mole ratio to find the moles of that guy. So if they don't give me moles of my first substance, in this case sodium azide, I have to get to moles. Well, they gave me mass, so I know I can go from mass of sodium azide to moles of sodium azide. And I know that once I've done that, then I can do my mole ratio to convert between substances. So that's just, you know, maybe more of like an intuitive type trick to problem solving. So we got moles of sodium azide because I know once I get here, I can cancel that out to get into moles of what I'm asked to find. Okay. And I know, again, I've mentioned that just a few times already, I don't want to talk about moles of sodium azide. I want to talk about moles, mass really, of nitrogen. Okay, so I know I want that to cancel. So I'm going to put moles of sodium azide in the denominator. Okay, that way they cancel. And this is a great opportunity for me to get out of one substance and into another by using the mole ratio. So I can compare the moles of sodium azide to the moles of nitrogen. But I'm asked to find the mass of nitrogen, so I still need to cancel those units out. So I can put the moles of nitrogen in my denominator so that they cancel. And I know that I can convert between the moles of one substance and the mass of that same substance. So I'm going to go ahead and put grams of N2 up top. Okay. I see that all my units cancel out, and I'm left with mass of nitrogen, which I was asked to find. So again, I'm going to go ahead and put that in my little answer. That way I don't forget. Okay. Now we need to fill out our conversion factors. The very first one that I will fill out is my mole ratio. Okay. Using the balanced chemical equation, I see that 3 moles of nitrogen are produced for every 2 moles of sodium azide that decompose. So 2 moles of sodium azide decompose to 3 moles of nitrogen. 3 moles of nitrogen are produced from 2 moles of sodium azide. Again, that just comes from the balanced equation. Got 2 more sets. Right here, I've got moles and mass of one substance and moles and mass of another substance, meaning I need to find the molar mass of substance 1 to use here and the molar mass of substance 2 to use here. So similarly to the last problem, let's kind of make like a little side note. Okay, I know I need to convert between moles and mass of sodium azide, so here's how to find the molar mass of NaN3. And I need to find the molar mass of N2. Okay. For sodium azide, I've got sodium, I've got nitrogen. I know that sodium is 22.99 grams per mole, and I know that nitrogen is 14.01 grams per mole. I've got 1 sodium, and I've got 3 nitrogens, so it's going to give me 22.99 grams per mole from the sodium. Okay, and 14.01 times 3 is going to be 42.03. Sometimes I don't trust myself, and some of you guys might be like, what? So let's do that. Yippee! Okay, if I add the 2 of them together, I should get something 0.02. Okay, so that's going to be 1, so 5, so 65, there goes my lights, hold on. 65.02 grams per mole is the molar mass of sodium azide, okay, meaning there's 65.02 grams of sodium azide for every mole of sodium azide. So I'm going to put this information right here up at the top. So every 1 mole of sodium azide weighs 65.02 grams, or 65.02 grams of sodium azide in 1 mole. Okay. For nitrogen gas, I've got just nitrogen, which is 14.01 grams per mole, but I've got 2 nitrogens in my N2 molecule, so that gives me 28.02 grams per mole. So there's 28.02 grams of nitrogen gas for every mole of nitrogen gas. 1 mole weighs that much. Okay. And my conversion factors are complete. My units are what they need to be. Now I can do the math part. So I'm going to take 100 and divide it by 65.02. Hit enter and leave it in my calculator. Okay. Now what I'm going to do is I'm going to multiply it by 3 over 2. Okay. So instead of making this complicated, you could do parentheses and do 3 divided by 2 and all that. I'm just going to multiply it by 3 and then divide it by 2 because it's the same thing. So times 3 divided by 2 and then multiply it by 28.02. This gives me, oops, oh man, I must have messed that up. Let's try it again. Got 100 divided by 65.02 times 3 divided by 2 and then times 28.02. There we go. Now we get 64.64 grams of nitrogen. Okay. So 100 grams will decompose to form 64.64 grams of nitrogen, meaning that whatever the difference in those two numbers is, it must be the mass produced for sodium. There you go.